look at what happens when we try to find the length of a curve in polar. If f is continuous and it has continuous derivatives on an interval, then the length of the curve from alpha to beta is going to be the integral from alpha to beta of the square root of f of theta squared plus f prime of theta squared. And usually we just use r, so square root of r squared plus the derivative of r with respect to theta squared. It's not the second derivative, it's the first derivative squared. Let's look at a problem. Suppose I want to find the arc length of my cardioid here. And I want the whole thing. So in this case, alpha is going to be 0 and beta is 2 pi. R is 2 minus 2 cosine theta. So dr d theta is 2 sine theta. So this becomes the arc length is equal to the integral from 0 to 2 pi. And yes, you could have done it in half. You could have used symmetry arguments and doubled it, but I'm not going to. Okay, times the square root of r squared. So this is 2 minus 2 cosine of theta squared plus 2 sine theta squared d theta. Now you can see this can become a very ugly problem very quickly, or it can simplify very, very nicely. And when I simplify this one down, I get this is the square root of what? This is 4 plus 2 times 2 is 4 minus 8 cosine of theta plus 4 cosine squared theta plus 4 sine squared theta. All right, d theta. Now these right here are going to reduce to 4. So this is the integral from 0 to 2 pi. 4 plus 4, the square root of 8 minus 8 cosine of theta. Oh wow, this is going to actually be not too terribly bad. So I'm going to factor that square root of 8 out. So this is square root of 8 times the integral from 0 to 2 pi, the square root of 1 minus cosine of theta d theta. All right, you're going to want to convert this, use a trig identity. So this is 2 root 2, integral from 0 to 2 pi of, let's see, 1 minus cosine theta becomes 2 sine squared theta over 2 d theta. All right, so when I simplify this down, it becomes 4 times the integral from 0 to 2 pi of sine theta over 2 d theta. Don't worry about absolute values. All right, and when I do this, I get an answer, I'm not going to do the integration because I'm out of room, of 16. It's not usually a nice, pretty number, but in this case it was.